water tank, you by using the steel material. Okay, so by using the steel material, how you going to design and draft in the AutoCAD by using the steel material, you're going to see. Okay, so what is the difference cement concrete as well as the steel structure, like it differentiated in all the aspects. Okay, even it starts from the activity. So from the activity, in it will follow shuttering, and you need concrete, and you need steel rods. Okay, steel rods you need. Okay, so together monolithically you manufacture, you material, so that is called reinforced cement concrete. Okay, in case of steel, like number of activities reduced. Okay, while considering or while compared to the reinforced cement concrete. Why? Because for the steel structure, shuttering now you not needed. Okay, so you need not to use the concrete. Okay, shuttering also not needed, concrete also not needed. Okay, in case of steel structure, only for the constructing the foundation alone you need the concrete and the steel rod. Other than that, for the superstructure and all, you need not need, you don't want to depend on the material of. Okay, so what you can do, so but analysis and this part it will be same. Okay, like for example, the virtual model will be done in the software and the load will be applied. Okay, so after the application, that particular load is making to the structure. Okay, so that we study. Okay, after studying that aspects, okay, so we consider the bending moment and shear force we design. Okay, at the end of the analysis part, so you get the like you get the desired result of bending moment and shear force. Based upon that, the design procedure will differ. Okay, so the like what is the intensity the structure going to fail. Okay, so based upon that intensity, you choose the sections we going to use. Like for example, sections are there. Okay, so it starts from the eye section, angle section, channel section. It differentiated based upon the shape. Okay, so not only the three types of section, we have other kind of steel also is available. Like for example, if you see the railways. Okay, railway compartment. Okay, so that compartment bottom and all, it is made up of steel. Not of the railways compartment also, it made up of steel only. Okay, so after completing the analysis part, you choose the desired shape of the steel unit, whether you need the plate, the thickness of it is available in different thickness. It starts from the 8 mm and it goes on. Okay, so like it manufactured in closed factory. Okay, so from the factory it can be transported, and you can proceed the construction process. So this is the steel. Okay, so the analysis part will not have any. If you go for the design, this is the thing you do. Okay, you decide the shape of a steel section you need. Okay, so which is available. After deciding the shape of the steel section, like you have to join the two steel section to get the desired structure. Okay, so whether it may be like anything, it may be building also, or it may be the industries, or it may be uh, any other public utility platform also. Like for example, like airports construction, and rail tracks. If you see the rail tracks and all, it will be in the I section. Actually, I section, it is and supported by the sleepers. Okay, so mostly they will use timber. Okay, in some of the cases they can go steel timber, steel sleepers also. Sleeper means like along the cross like the two rails. Okay, so after that, if you go for the compartment construction also, the steel plates can be utilized. Okay, so based upon the application and the load intensity, uh, appropriate shape of the steel section, as well as you decide the type of connection also. Once you go for the steel section, construction and all. So the connection is the most important part. Okay, so why the connection is important part? Like it has to be, the two section has to be connected by, or it can be welded also. Okay, either you can go for the welded, and whether you can go for the bolted connection. Okay, so you decide this also. Okay, so what is the type of connection you don't miss the sequence. Okay, so the first thing to be known is analysis. Okay, so after analyzing, you are choosing the desired shape of the steel section. Okay, so after section, what you do, so you go for the type of connection you're going to follow. Okay, so whether it is a bolted connection or it is a welded connection. Okay, so after deciding that parameter, you can go for the, like, you have decided bolted connection means like what, how many number of bolts you have to provide. Okay, so what is the dia of the bolt you're going to provide for this, are on this and all guidelines are there. Okay, so Indian, okay, so the code book which is used for the steel section design is like IS 800 2007. Okay, so this is the Indian standards for design of steel structure. Okay, you can use that code bolt, and you decide the dia of the bolt also. After deciding the number of bolt and dia of the bolt, you detail. Okay, so this is the thing related to the connection. Not only that, you have to detail what are the different types of structural components which is going to be used in that particular structure. Okay, so these are all the design procedure for the steel structure. Okay, so this designing the steel structure. Okay, what are the things I have told? It is a generalized process. Okay, so how can you go for the specific process? So the specific process means like what is our structure? Okay, structure. Experiment number 4, design of steel structure. Okay, so that is design of water tank by using the steel structure. Okay, so that is the what we're going to do. Okay, so we're going to cover the parameters, and we're going to cover the consideration load to be applied. So those are all the factors we're going to see for the system. I'll share the screen for that. Can you able to see the screen?
Yes, sir.
Yes, sir.
Can you able to see the screen? Can you able to see the screen or not?
Yes, sir. It's
Sir.
okay.
Okay,
Yes,
okay, fine. First we'll see. Okay, so different purposes for which the steel tank is designed. Okay, so they are given the 3 classes actually. We'll start from the classes 1. Okay, so the classes 1 is a tank and tank containing waters. Like for example, this is the irrigation purposed steel tanks which is used in the agricultural field. Okay, on the requirement, it can be the groundly rested. Okay, so it can be rested on the ground, as well as it can be placed at the elevated height also. Okay, so this is the first class. Okay, so if you go for the second class, what is the type of tank? So it is a medium sized tank which stores the flammable liquids or water, polluting liquids in urban area. Like for example, this this is majorly used in the petrol stations. Okay, so petrol stations will be there. Okay, so those type of tank is there, no, below the ground surface, not only not above the ground surface. It will be rested below the ground surface. It shows the flammable liquid. Okay, so liquid and diesels are the type of flammable liquid. It shows that type of liquid. Okay, so uh, in other utility, it can be used in urban areas for storing the class 2 water tank. Okay, so the class 3 water tank is there, no. So this tank is used storing the liquids and liquefied gas with toxic or explosive and large size with the flammable liquids or water polluting liquids in urban area. Emergency loading should be taken into the account for those structures wherever necessary. Okay, so this is consequences like it shows the variety of liquids. Okay, so whatever may be the nature, it shows all type of liquid. It is in large, it's large size type. Okay, it predominantly used in the urban areas. Okay, for storing the toxics. Okay, so this is the nature of the third class of steel structure. So if you see the if you see among the three types, so what you can understand, so that it is differentiated based upon the purpose. So after differentiating the based upon the to decide the nature, for example, steel plates only you will be using in case of steel structure and all. Okay, so you decide the thickness of the steel plate based upon the it is used. Okay, so for example, if it carries the flammable liquids or flammable toxic potential liquids, so those kinds even in the RC, in the reinforced concrete structures also, it has a chance. Okay, so porous medium will be there. Okay, so it can penetrate into the porous of that particular material. Okay, but the steel can stop that penetration to some extent. Okay, so that is the thing, that is the reason also steel design. Okay, so steel design. Okay, so what is the first step, while designing the water tank? Okay, steel water tank. Okay, so the first step is okay, so you identify your own purpose. Okay, like for example, for the residential purposes, for storing the water tank and for storing the water and all, so you can go for this class. The class 2 and class 3 are used for the purpose of storing the toxic and flammable liquids. Okay, so for the residential you can go for the class 1. Okay, so this is the purpose. After identifying the classes, okay, class of steel water tank you're going to use. Okay, so this is the first step. Okay, so the second step is there, no, partial factor considerations are there. Okay, so why to consider the partial factors, so this is the factor of safety actually. So this is the factor of you design the structure based upon your assumption of load. Okay, so if the load exceeds in some particular once again, see this screen. Can I able to see the screen?
Yes, sir.
Okay, fine. Okay, so the second step is to choose uh, partial factor for action. Okay, so first before going into this, you just know what is the role of the partial factor. Okay, so the partial factor are partial based upon the assumption only you are designing the any structure. Okay, so based upon the assumption you are designing, so if any cases like the limit of the load exceeds your assumption, then failure will happen. Okay, so for that purpose only you choose the some partial factors. Okay, so considering the two so based upon the action they choose the partial factors, and based upon the resistance also. Okay, so they decide the partial safety factor. Okay, so what are all the values it is there, and corresponding design situation. Okay, so what purpose you are deciding. Okay, like for example, the first thing is the liquid induced there are different types of load is there. Like for example, you design the structure, dead load, live load, wind load, earthquake load, snow load. Okay, so there are 5 type of load is there. Like you consider all those 5 types of load. Okay, so based upon the location where you're going to design and also the nature of the structure. Okay, so similarly, the tank is meant for storing the any liquid, any kind of liquid. Like so what kind of liquid it going to store? Okay, so induced load during operation. Okay, so when the water or any liquid is loaded loaded in the water tank, what kind of loading operation it can under loads is there. Okay, so the first one is toxic, explosive or dangerous. Okay, so the second one is flammable liquids like petroleum and diesel. Okay, so which stores the drinking purpose liquid also and for the purpose of agriculture, and in sometimes it stores sometimes wastage utility liquids also. Okay, so these are all the different kinds of liquid. Okay, so corresponding to the types of liquid, the load induced load induced factor of safety you can choose here. Okay, so there are 2 types of factor of safety they are given. Gamma f in case of variable action from the liquid, permanent action from the liquid. Okay, like for example, if it is flammable liquid, flammable fluid, it tends to react. Okay, if the reaction is uniform, then you can choose the value from non-uniform, you can choose the value from here. Okay, so that is the thing. Okay, so the second thing, so the first is during loading operation. Okay, so the second thing is during testing, in the sense like you test the capacity of that particular water tank, so that is during testing. Okay, so the so for the and accidental action also, the fluid type is all fluids. Okay, so there is a recommended value. Okay, so it is a factor of safety. Okay, so the factor of safety is given, you choose the factor of safety conditions. Okay, so second kind of factor of safety is there, no, this is the partial factor, that is the partial factor of safety for the resistance. Okay, so it depends based on this particular condition. Okay, so what are the conditions they are given? Resistance of the weld or bolted shell wall to plastic cross sectional resistance. Okay, so like for example, what is the resistance of the weld and bolt? Okay, so to ensure the weld and bolt resistance to the application of the load, you can value as 1. Okay, so as per the guidelines. Okay, so the second case, resistance of the shell wall to stability. Okay, so for to ensure the stability, okay, then considering the stability of the water tank only, but the thing is to have the factor of safety in that aspect, you choose this value. Okay, so 1 and or third one. Okay, so the fourth one is resistance of the welded bolt wall to rupture. Okay, so the first case is to plastic set and the second case is to the rupture. Okay, so what do you state and rupture and all, first of all I'll say what you mean by rupture first. Okay, rupture is the failure point. Okay, so like for example, there will be elastic point, since it is a steel, it has a elastic, there is a elastic point, elongation space will be there. After the elongation, the failure will happen. Okay, so that is the rupture. Okay, so the steel structure can be, so then we'll go for the plastic sheet. Wow, plastic sheet is nothing but at the point where the material loses its elasticity. Okay, so that is called plastic sheet actually. Instance for the plastic state, and what is the current partial factor of safety can be chosen. Okay, so similarly in the third case, resistance for the rupture, that is the failure, it can be chosen. Okay, so the next category, resistance of the shell wall to the cyclic plasticity, and the fourth one is resistance of the welded or bolted connection or joints. category is the resistance of the shell wall to fatigue. Okay, so fatigue means failure. Okay, so these are all the different kinds of category, and as per the aspects. Okay, so as the design goes, okay, so corresponding or while designing for that particular element, you can take the values. Okay, so you can take the partial factor of safety for the resistance aspect, for as well as for the we can you can refer it here. Okay, so this is the thing. Okay, so the what is the fourth thing, so it is the calculation of load liquid in terms. Okay, so like for example, the steel tank also has its own weight. Okay, so you consider the self weight of the water tank afterwards. Okay, so after considering the self weight of the water tank, so what which going to be stored. Okay, so that it can be calculated by this expression T z is equal to gamma z. Okay, what is the z? Z is the depth of the liquid, gamma is the density of the liquid. Okay, so therefore from this expression you can have the inference like the liquid in the liquid which is stored in the water tank, it depends upon the depth of the liquid as well as the density of the liquid. Okay, so you know what do you mean by density. Okay, so you consider the liquid densities are there. Okay, so like for example, water, the density is 1000 kg per millimeter cube. Okay, like for the petroleum products, so for the petrol, okay, so the density will be 700 meter cube. Okay, so this is the density. Okay, so the liquid load depends upon these two factors like density as well as the depth of water is stored. Okay, so in the below itself they are given the density value of water actually. Okay, so the density of the value of water meter cube in kg per meter cube. I have told in kg it is 1000 kg per millimeter. Okay, so this is the next step in the. Okay, so after considering the factor of safety and after calculating the load intensity and deciding the type of tank you're going to design, so you're going to model the water tank. What are the things you decide? You decide the dimension and you decide the thickness of the plate. Okay, so the thickness wall plate you're going to use, and you choose the base thickness also. Okay, so you choose the base thickness also. Okay, so this is the different dimension calculation you do in this particular phase of design steel water tank actually. Okay, so as I told, when modeling a rectangular or any shape of water tank, it is necessary to follow the following instruction. Okay, so you're going to do, okay, you decide the dimension, you're going to decide the wall thickness and all. Okay, so some of the instruction they are given. What are the instruction? So the first one is concerning the resistance and stability of the out of the plane actually. Okay, so like for example, the flat plate steel plate you're going to use, so you calculate the resistance and stability of the particular flat plate. Okay, you can calculate by conducting the experiments. Okay, so in the laboratories you conduct the experiments based upon that test values. You your design so that you decide the resistance and stability. Okay, so if the resistance or the stability, how much intensity that particular flat plate can withstand, so you consider that and then you choose steel flat plate actually. Why? Because it is available in different dimension. Okay, so you decide the dimension and you decide the thickness of the flat requirements you are. Okay, so like for example, for the massive structures, okay, so it is going to store the and it's going to have the larger liquid in those case, like you consider the condition first. Okay, so after considering the condition, then you decide the flat plate dimension and flat plate type also. Okay, so the second consideration, so dimension stiffness. Okay, it is necessary to determine the effective path width. Okay, with each side of the stiffness should not be higher than the, like they are given some expression NT. Okay, so where T is the local plate thickness and N 15 epsilon. Okay, so 15 epsilon is nothing but strain value. Okay, so while choosing the flat plate, the thickness. Okay, not only you should not you should leave up to that. Okay, you consider the local flat plate thickness also, as well as you consider the strain value 15 epsilon. Okay, so this is the thing you're going to do. Okay, like the next thing, so there are different types of tanks. It can be designed. Okay, so after considering all the aspects. Okay, so the first type of tank, it is while it has a steel wall all around. Unstiffened means there is no support at the walls. Okay, so this is called unstiffened tank type. And the second type, so they are providing some of the stiffness. Okay, so this is the stiffness actually. Okay, while you see the figure 1 as well as the figure 2, there is no support for the wall. First type unstiffened tank. In the second case, so there is a stiffness. Okay, so the stiffness are supporting the walls of the water tank. Okay, so there is a stiffness horizontally. And in some of the case, the stiffness are supporting the wall. Okay, wall of the steel tank in the horizontal direction as well as in the vertical direction also. Okay, so the providing the stiffness, the spacing between the stiffness, and you decide the horizontal or vertical stiffness requirement and all, depends on the depends on liquid load as well as the dimension. Okay, so if you see here, the first case, the dimension will be lesser. Okay, so as the dimension increases, the sulfate of the water, the sulfate not not only that, the liquid intensity, the liquid load also will increase. Okay, so due to the increase in the load, you provide increase the number of flows also in the horizontal as well as the vertical direction also, itself. Okay, so now you can able to know what is the steel tank, and in the steel, any steel structure also the stiffness will be provided. Okay, so you know the role. Okay, so now the next thing to be known is, like, if not provided means what will be the consequences. Okay, so what kind of failure will be happening. Okay, so like for example, in the first step, even though stiffness are provided, okay, you consider the case 2 and case 3. Okay, so this is the case 2 and case 3. Okay, so in the case 2, additional stiffness are provided. If it is not provided, means in this case 3 also the provided. Okay, if it is not provided, what will be the consequences? The consequences is buckling will happen. Okay, so the buckling, like for example, the shape, the still water tank will be changed actually. Okay, so in which way, so the buckling will be done. Okay, so the buckling will happen in the vertical as well as the horizontal direction. Can you able to see the screen? Can you able to see the screen?
Yes, yes, yes.
Correct, correct.
Like the water tank has a larger dimension and stores the high intensity of the liquid also. Okay, so this is the way the liquid will be stored inside the water tank. You consider the here. Okay, so you consider the some liquid is stored inside the water tank. Okay, so how the liquid will apply the load in the walls of the water tank, so it will try to push the wall in this way. Okay, so like this. Similarly, the load will be applied on the wall like this. Okay, so like horizontally, the wall will be subjected to some intensity of the load action. Due to this application of the load, so the buckling will happen like this. Okay, so like the length of the water tank may be reduced due to this action. Okay, so this is the way the horizontal force applied and the buckling is will happen in this way. Okay, so this is the thing. So to provide the stiffness. Okay, can I able to see the screen? Can you able to see the screen?
Yes, sir.
Yes, sir.
After the dimension of the structures, okay, like as I told, like different the steel water tank is constructed by using the more number of plates actually. Okay, so here, okay, so with the different dimension, it will be like this. Okay, so after choosing the dimension, it will be connected together by using the by using the bolt as well as the weld. Okay, so like this the also will be connected together. Okay, so after that it transported and placed in the construction site as per the dimension, as per the positioning of that particular so if you see here, they are mentioned about the load calculation here. Okay, so what is the load calculation? Like it is the bottom of the water tank and this is the top of the water tank. Okay, so density of the liquid also they mentioned it as 10 kilonewton per meter cube. Like as the height, the intensity of the water will be reduced. Why? Because at the base only the water will impose the maximum load. As the height goes on decreases, at top there will be there will be no load. Okay, so after 1 meters from the top, okay, so the liquid load. Okay, so at 2 meters, okay, so this is the intensity at 2 meters. The intensity is 20 kilonewton per meter cube. Okay, similarly for at the intensity 25 kilonewton per meter cube, and at the three, okay, so at the bottom, so the overall height of the wall, the overall height of the water tank is 3 meters only, and at the bottom it up towards the bottom portion of the water tank. Okay, so you decide the thickness accordingly. Okay, so this is the way, this is the reason it is represented in that way. Like for example, at the bottom and all maximum thickness. Okay, the thickness is represented as the height goes. Okay, so at the top, thickness of the steel plate can be reduced. Okay, wisely. Okay, so based upon the load intensity. Okay, so this represent the thickness actually, and this represent the height actually. The bottom has the maximum thickness and top amount lesser thickened steel plates. Okay, so that is the thing. Okay, so after that load calculation based upon say the thickness as well as the dimension. Okay, so there are different dimensions are there. If you see here, three steel plates they are using here. Okay, so that in among the three steel plate, and the thickness they are given actually. Okay, so this is the thickness. Okay, in this case the breadth also decreased and thickness also decreased. Okay, so in the second case, the third case is similar to the first one. Okay, so the different kinds of steel plates in the steel structure. Why? Because load is different. Okay, so at the bottom the load is will have the small top, the load will have the max small intensity. Okay, so this is the way you choose the different kinds of steel plates, and this all the steel plates are together joint, will be together joint actually. Okay, so that, so based upon the load calculation, based upon the load calculation, you decide the type of after connecting with the bolted or welded, so whether it is stable. Okay, so you ensure the stability also, and you ensure the safety actually. Okay, okay, deflection. Okay, so at different points they calculate the deflection. Why to calculate the deflection? So the deflection is the only way, the deflection check is the only way you able, and you ensure your structure is in the usable condition actually. Okay, so why to consider the deflection? Like, okay, so even it is in the safety zone also it will deflect actually. Okay, so for example, the beam in your residential home, so that will deflect. See the deflection. Why? Because it is very minimal. Okay, like the thing is you have to ensure the minimum deflection actually. Okay, if it is exceeding the permissible limit, then you have to go for the redesigning the structure. Okay, so you design the structure again. So after redesigning the structure, what you are doing, after redesigning, you go for the detailing again. Okay, so this is the way you proceed your design. Okay, so some of the detailing they are given. Okay, so as of, okay, so they decided the thickness of the steel plate going to use, and what is the dimension. Okay, so like for example 3 meters is the overall height. Okay, so they are as well as the thickness of the, here they are given the thickness of the plate, you can see here. Okay, so this is the three different kinds of whereas the first and second case will be used at the bottom of the water tank, and the second case will use at the top of the water tank. And after deciding all those things, what type of connection you're going to follow. Okay, so you can go for the bolt by the conventional method. In the steel section you could have come across about how to decide the number of bolts. Okay, after deciding the number of bolts based upon the load intensity. Okay, so then you ensure the factor of safety also. So what is the factor of safety? Like deflection permissibility. Okay, so you ensure the factor of safety in that aspect. Okay, so after deciding all those things, like as of now you have completed the dimensioning, as well as you completed the thickness of the, you completed the type of connection also. Okay, so as of now the design also completed, and after that what are you going to do? The dimension of the water tank is over. Dimension of the water tank is over. Okay, since it is the height of the water tank is more, that is the liquid weight which is going to be stored in that particular steel water tank is more, you're going to provide the stiffness. Okay, so I have shown about the stiffness and pictures of the stiffness already. You see here. So okay, this is the stiffness. Okay, so after designing the water tank part, then you go for the design of the stiffness actually. The stiffness and number of stiffness, and what kind of steel section you're going to use for that particular stiffness. Those things you're going to see. Okay, so for that all calculation you have to do. Okay, you're going to use the angular section for this, for providing the stiffness for this water tank. Okay, so you're going to, it will be provided like this option, placed together and it is joined. Okay, so based upon the load intensity only, like if the load intensity less, the stiffness can be placed as a single angular section also. Okay, so in this full angular section. Okay, so this is the thing, so you provide in this type. Okay, so doubler angular section you're going to provide, and two kinds of stiffness, vertical stiffness y2 and vertical stiffness y1. Okay, so the two kinds of there, it differentiated on the thickness actually. So the in the first case the thickness of the angular section, in the second case it is 6 mm. Okay, so similarly the web section thickness also is reduced. In this case it is 4 mm, but here okay, but there will be no change in the width. Actually the width of the water stiffness is 20.4, and here the width of the water tank also is similar. Okay, so like here, okay, so only small variation is there. Okay, so in this case of a particular water tank you're going to provide the stiffness like this. Okay, so this is the thing, the picture here. Okay, so above this your steel water tank will be placed. Okay, so above this the steel water tank will be placed, and this is the kinds of stiffness they use. Stiffness is provided not only to resist the load, liquid load, it also used in case of the horizontal and in the equilibrium position. Okay, so this is how, this is the kind of stiffness. Okay, so the overall height is 3 meters, and you provide the in the segments. Okay, so the segments is joined together. Okay, and this is the thing. Okay, so this is the overall view of the design after constructing the water tank. The stiffness are provided in the horizontal as well as in the vertical direction, and in the angular direction also it is placed. Okay, so this is the drafting, we will cover it in the subsequent class. Okay, so this is the modeling picture which is there. Okay, so this is the thing, it will not show any dimension and all, but in case of I will show the dimension. Okay, so and connection details also. For example, like what is the number of bolts? Okay, so you will be showing in that that also what is the number of bolts, dimensioning as well as the different parts of the steel water tank here. Okay, so in answers they are analyzing to ensure tank actually. Okay, so this is the thing.